Okay, guys, so this is going to wrap up our rational functions lesson. So we're going to talk about rational functions and asymptotes. This is a super important lesson, especially for calculus. Remember that a rational function is given as a fraction, so it's two functions divided by each other where the bottom cannot equal to 0. So that's what this top definition is. Okay, so we're going to find the domain of some rational functions. Remember, the domain is going to be negative infinity to positive infinity, where the bottom cannot equal to 0. So on this one, the bottom cannot equal to 3. Okay? We're going to factor on the next one. So factors of this, x plus 2 and x minus 1. A lot of times these are going to factor, so don't freak out if you have to do a lot of factoring on this. Okay? So the domain of this is going to be negative infinity to positive infinity. X cannot equal to a negative 2, and x cannot equal to 1. In the last one, it's already factored for you. Your domain is going to be negative infinity to positive infinity. X cannot equal to 2, and x cannot equal to a negative 4. Okay, so the next thing we're going to talk about is horizontal asymptotes. So horizontal asymptotes are going to be your top-heavy, bottom-heavy rules. So if the power on top is greater than the power on bottom, there's no horizontal asymptote. If the power on top is equal to the power on bottom, you divide the leading coefficients to get your horizontal asymptotes. If the power on bottom is greater than the power on top, you're going to have a horizontal asymptote for the line y is equal to 0. Okay? So top heavy, bottom heavy rules, it'll make more sense when we do examples. You're going to have vertical asymptotes where the bottom is going to be equal to 0, where the denominator is equal to 0. If something cancels on top and bottom, this is called a removable discontinuity. So that's a hole in the graph. Okay? So as we go through these examples, we're going to find the domain, vertical asymptotes, horizontal asymptotes, intercepts, and removable discontinuities. Okay, first one. When we add and subtract fractions, we're going to get a common denominator. So this one's missing an x. So we get 2x plus 1 over x. So we're going to find our domain. Our domain is going to be negative infinity to positive infinity. X cannot equal to 0. Vertical asymptotes is where the bottom is equal to 0. So x is equal to 0. Just set that equal to 0. Horizontal asymptotes. We'll say it's HA. Now, the power on top, highest power on top is 2x, highest power on bottom is x. They're the same degree, okay? So we're going to divide the leading coefficients. So 2 divided by 1 is 2, so it's line y is equal to 2. Your x-intercepts is where the top is equal to 0. Okay, so x is equal to a negative 1/2 is your x-intercept. To find a y-intercept, we plug in a 0. Okay, we can't plug in a 0 because we'll have division by 0. So y-intercepts is none. And since nothing canceled top and bottom, your removable discontinuity is none. Okay. Next one. Okay, so our domain, we're going to set the bottom equal to 0. Because that's where vertical asymptotes are going to occur. So x cannot equal to 0, and x cannot equal to a negative 4. Since nothing canceled top and bottom, your vertical asymptotes are at x is equal to 0, and x is equal to a negative 4. Your horizontal asymptotes. Okay, horizontal asymptotes, your top heavy, bottom heavy rule. So the highest power on top is x. The highest power on bottom is x times x, which is x squared. So this is going to be bottom heavy. When it's bottom heavy, your horizontal asymptote is y is equal to 0. Your x-intercepts, you set the top equal to 0. So you get x is equal to a negative 1. Your y-intercept, you're going to plug in a 0 for x. So you can't do that because it's not in the domain, so this is none. And removable discontinuities, are also none because nothing canceled top and bottom. Okay, so don't freak out if you don't have any removable discontinuities or Y-intercepts. Just go with the flow on it. Okay, domain for the next one. It's negative infinity to positive infinity. X cannot equal to 1, and x cannot equal to a negative 2. You'll have vertical asymptotes at x is equal to 1, and x is equal to a negative 2. Horizontal asymptotes. Highest power on top is x. Highest power on bottom is going to be an x times an x, which is x squared. You can FOIL that out if you wanted to, but you can just tell by those leading terms. So it's going to be bottom heavy, so it goes to y is equal to 0. Your x-intercept is where the top's equal to 0, so it's x is equal to 0. Your y-intercept, we're going to plug in a 0. Okay, so 0 over anything is 0. Removable discontinuity, or hole, is none because nothing cancels top and bottom. Okay, on this one, we're going to have to factor. So x minus 3 and x plus 2. So your domain is going to be negative infinity to positive infinity. X cannot equal to 3, and x cannot equal to a negative 2. Your vertical asymptotes is going to be x is equal to 3, and x is equal to a negative 2. Horizontal asymptotes, you don't have anything on top, and you have an x squared on bottom, so it's going to be bottom heavy. So it's going to go to 0. X-intercepts, 6 will never equal to 0, so none. Y-intercept, plug in a 0. So 0 minus 3 is a negative 3, times 2 is a negative 6. So 6 divided by negative 6 is negative 1. And removable discontinuity is none because nothing cancels on top and bottom. Okay. So we need to factor. If it looks like it factors, it probably does factor. So this factors to x plus 4, x minus 3, all over x minus 4. So your domain is negative infinity to positive infinity. X cannot equal to 4. So we set our bottom equal to 0. Your vertical asymptote is x is equal to 4. Horizontal asymptote, highest power on top is x squared. Highest power on bottom is x. So it's none because it's going to be top heavy. X-intercepts. Set the top equal to 0. So you get x is equal to negative 4. X is equal to 3. Your y-intercept, we're going to plug in a 0. So negative 12 over negative 4, which is going to be 3. And then removable discontinuity is none. Okay, there's some removable discontinuities in here, I promise. Next one. So this is going to factor to x plus 5 and x minus 2 all over x plus 5 and x plus 3. Okay, so we're going to stop here and we're going to do our domain. So our domain is going to be negative infinity to positive infinity. Set the bottom equal to 0. So x cannot equal to a negative 5 and x cannot equal to a negative 3. Okay, your vertical asymptotes. Now watch this. This is going to end up canceling. So the only thing left on the bottom is going to be an x plus 3. So your vertical asymptote is x is equal to a negative 3. Horizontal asymptote, highest power on top and bottom, they're the same. So we divide the leading coefficient, so you get y is equal to 1. X-intercept is going to be x minus 2 is equal to 0, so x is equal to 2. Your y-intercept, we're going to plug in a 0, so negative 2/3. And we're going to have a removable discontinuity. Now watch this, because we haven't done this before. So we're going to set x plus 5 is equal to 0. So whatever we canceled equal to 0. So you're going to have a hole in the graph at x is equal to a negative 5. And that's how we do removable discontinuities. Okay. Next one. Our domain is going to be negative infinity to positive infinity. X cannot equal to 1. Vertical asymptote. We have a vertical asymptote at 1. Horizontal asymptote. Same power, top and bottom, so it's going to be y is equal to 2. You're going to divide the leading coefficients. X-intercepts. It should be negative 2. Y-intercept, plug in a 0, so 4 over negative 1, so it's negative 4. And removable discontinuity is none, because you're not canceling anything top and bottom. Okay, next example problem. We already did that one. Okay, that's a repeat. We're not going to do it again. It's the same one as this one up here. Okay, so we're just going to hit boom it on that. Okay, next one. X squared minus 16. That factors to x plus 4, x minus 4, and x squared plus 25. We know that sum of squares does not factor. Okay, so we don't mess with that. So our domain is going to be negative infinity to positive infinity. X cannot equal to 4, and x cannot equal to a negative 4. Your vertical asymptotes are going to be negative infinity to positive infinity. Oh, sorry. Your vertical asymptotes are x is equal to 4, and x is equal to a negative 4. Your horizontal asymptotes, highest power on top, you don't have any x's on top. You have x to the 4th on the bottom because x squared times x squared gives you x to the 4th. So it's going to go to y is equal to 0. X-intercept, 6 will never equal to 0, so none. Y-intercept, we're going to plug in a 0. For x, I'm going to have to use a calculator on this. So 6 divided by negative 16 times 25. I get negative 3 over 200. And nothing cancels top and bottom, so we're not going to have a discontinuity. Okay. Okay, last two, and then we're going to talk about how to find asymptotes looking at a graph. Okay, so top one. Nothing's going to cancel top and bottom because it's already factored for you. So our domain is going to be negative infinity to positive infinity. X cannot equal to 0. X cannot equal to 4. So I'm just setting the parentheses equal to 0. I don't have to worry about the squared. Just set the parentheses equal to 0. Okay, vertical asymptotes. X is equal to 0 and x is equal to 4. Horizontal asymptotes. Okay, so I have x times x is x cubed on the top. I have x squared right here times an x, so I'll get x cubed on the bottom. So they're same power top and bottom, so I'm going to divide the leading coefficients, so it's y is equal to 1. Your x-intercepts, we set the top equal to 0, so it's x is equal to 1, x is equal to a negative 2, and x is equal to 3. Y-intercept, plug in a 0, you can't because it's not in the domain, so put none. And removable discontinuity is none. Okay, last one of these. So the top is going to factor to 4x plus 3 and 2x plus 5. Go on and do PSF for that. And the bottom's going to factor to 2x plus 5 and x minus 3. Okay, so we're going to get this to cancel in just a second. So our domain It's going to be negative infinity to positive infinity. X cannot equal to negative 5/2. And X cannot equal to 3. Your vertical asymptotes. So your vertical asymptotes are going to be, so it's going to cancel that, so that's a whole. So just at X is equal to 3. Horizontal asymptotes. Highest power on top and bottom. 8 divided by 2 is 4, so it's the line Y is equal to 4. Your X-intercept is where the top is equal to 0, so it's going to be negative 3/4. Your Y-intercept is when we plug in a 0, so I get 3 over negative 3, so it's going to be negative 1. Removable discontinuity is at X is equal to negative 5/2. So I set whatever I cancel equal to 0, and I solve for that. Okay, graphical examples. So what do asymptotes look like? So vertical asymptotes is where it comes up to it but doesn't touch it. So on this graph right here, Y equals 1 over X, we would have a vertical asymptote at X is equal to 0, which makes sense, it's not touching it. And our horizontal asymptote is what it lines out to going this way. So it's Y is equal to 0. Okay? If we're looking at this one, Y is equal to 1 over X squared. Okay? So I see that I have a vertical asymptote here. It's approaching it but never touching it. So your vertical asymptote would be X is equal to 0. And this would be bottom heavy. So because you get an X squared on the bottom. So it's going to go to 0. Okay? So they both approach 0, go in both directions. And, you know, you see that this goes up to infinity. So anytime something goes up to infinity, it's going to be an asymptote. Okay, and so we got something like this. And just kind of looking at the graph, we're not going to really go through it because it already gives you the answers. So from this, we can see that we're going to have asymptotes at X is equal to a negative 3, vertical asymptotes at X is equal to a negative 3, and X is equal to 2. Now, if we're looking at horizontal asymptotes, this is X cubed on top and X cubed on bottom, so it should line out to the line Y is equal to 1, and we see that. Now, you can never cross a vertical asymptote, but occasionally, if you have a graph that looks like this, where you have something going on in the middle, it can cross a horizontal asymptote. But if you see something like it says the end behavior, that means we're taking a limit as it goes to infinity or a horizontal asymptote. So as we go both directions all the way out to the left and the right, it's going to line out to be a Y value of 1. Okay? So this has been rational functions and asymptotes. I know I went through this rather quickly, but it's pretty easy. It's not bad. Remember, we're going to factor the denominator and set it equal to 0. If something cancels top and bottom, it's going to be a removable discontinuity. Whatever's left on the bottom is a vertical asymptote. Your horizontal asymptote rules follow your top heavy, bottom heavy rules, which are given right here. And to find an X-intercept, you set the top equal to 0. And to find a Y-intercept, you're going to plug in X is equal to 0. So, thanks, and have a good night.